So welcome all of you to the session on IoT data visualization using AWS QuickSight. So we'll start the session now. So I welcome you all for this session. So I'll introduce myself. I'm Bapuji Kanpati. I'm the founder and director of Appleton Innovations. So I have more than 10 plus years of experience in training and research. So I'll be teaching you now how to visualize IoT data using AWS QuickSight. Right. So most of us know what are the IoT devices, right? So let us see one example here, one IoT device. All of you can see one IoT device here. This IoT device is for predictive maintenance. This device is IoT based predictive maintenance application. So you will see there are three sensors here. So see this particular picture, all of you. So this is LoRa based predictive maintenance sensor. So which is based on LoRa technology, long range wireless technology. And there are total three sensors are here. One is current sensor, another one vibration sensor, and thermocouple is also here, thermocouple. So there are total three sensors, and connectivity is LoRa. Basically these are interfaced to a microcontroller, right? So using this particular wireless sensor, we can collect continuously vibration data, current sensor data, temperature data. Okay, so in industries there are many machines generating data continuously. So machines generate data, maybe some devices like home automation devices or weather stations and smart city projects. There are many IoT devices today existing in the world. All these devices basically generate data. Okay, so you will see in industry proximity sensors, limit switches, laser sensors, photoelectric sensor, capacitive proximity sensor, magnetic proximity sensor, and there are many other wireless IoT based sensors are existing. Okay, so what we are going to do now is simple. The objective of this particular webinar is to give you overall understanding of how to visualize IoT data, using AWS QuickSight. So I'll be showing you end to end, like how to generate data and then how to take this data to AWS QuickSight and visualize the data in AWS QuickSight. So I'll be showing you all the steps. The goal is how to visualize IoT data using AWS QuickSight service. Right. First, we need to understand if you are new to IoT or other fields. So I'll be giving you some introduction on IoT. What is Internet of Things? So Internet of Things can be defined as network of physical objects. We can define IoT as network of physical objects. Okay, so physical objects, or we can say network of things. Okay, so things like it can be a generator, diesel generator, or it can be a watch, or it can be a bulb. When we connect these things to the internet, these things can communicate. Okay, they can share information. Okay, so once you connect a thing to the internet, basically they communicate, they share information. Okay, so let us take a simple example as we discussed. Take a simple example. Suppose you have a vibration sensor, and you have temperature sensor, and third one is basically you have current sensor. Suppose, let us take this example. How to design IoT device to gather all these three parameters. Like we want to collect vibration data, we want to collect temperature data, we want to collect current data from a machine. So to collect data, you need microcontroller or a microprocessor. So let us take in this example microcontroller. plus you need sensors. So you can get sensors in the electronics market. So you can interface that sensor, vibration sensor, you can connect to the microcontroller, temperature sensor, you can connect to the microcontroller, current sensor, you can interface with the microcontroller. Once you do interfacing with the microcontroller, the next step is you have to add connectivity also, because we want to connect this entire device to the internet to send this data, vibration data, temperature data, and then current data to the cloud. Okay, for example, in our case, we are using AWS cloud. To send data to AWS cloud from microcontroller, there must be some connectivity. So you can provide connectivity by using communication technologies. There are different types of communication technologies existing, right? LoRa, so short range wireless communication technologies are existing. Long range wireless communication technologies are existing. So short range, you will give examples such as Wi-Fi, Bluetooth, or you can take example like um, BLE, okay, and Zigbee, Jetwave. All these are basically short-range communication technologies. Whereas long-range communication technologies, LoRa, Sigfox, cellular, 3G, 4G, 5G, all are basically long-range technologies. Okay, so we need communication technology. Okay, along with the microcontroller, you need sensors, and also you need communication technology. Okay, once you interface everything, you have to write the firmware. You have to write a firmware. So that is a program that you write inside of a microcontroller to collect data and also to transfer data from microcontroller to the cloud. Basically, you need to write a program. That program is called as firmware. So everything together, like microcontroller, firmware, communication, sensors, and circuitry, everything together, we call it as a IoT sensor or IoT device. Okay, all of you. Right? Do you understand this, all of you? Right? Okay. So we can define IoT device as a network of physical things, and each thing is embedded with sensors, microcontroller, and then you embedding with firmware, connectivity. Okay, so everything together we call it as a IoT device. Okay, so and each device, when it is connected to the network, it will have its own identity. Okay, so unique identity. That unique identity is called as IP address. Okay, so for example, let us take a simple example here. Simple example, suppose there is a plant and you want to monitor continuously this plant, like soil moisture. What is the soil moisture? What is the temperature? And what is, basically CO2? Okay, you want to monitor all these parameters for this plant. To monitor all these parameters for this plant, you need to interface a microcontroller with all these sensors. You need temperature sensor, you need soil moisture sensor, you need CO2 sensor. You interface them. And also you need connectivity. So for connectivity, you might be using some Wi-Fi module, interface a Wi-Fi module. Okay, once you interface a Wi-Fi module, you can provide internet to this particular device using Wi-Fi access point or Wi-Fi router. Wi-Fi access point or Wi-Fi router. You can do that. Okay, once it is connected to the network and having internet access, then this plant can communicate with the Facebook. It can communicate with anyone in the Facebook, because through the internet we can access Facebook, right? So users, right? It is possible. So directly the plant can post a post in the Facebook. It can interact. It can send messages. Okay, all these things are possible if you connect the plant to the internet. Okay, this is one example, right? So when you see the IoT architecture, when you are building an IoT product, basically there are three important things. Okay, I am simplifying this IoT architecture here. Okay, this is a simplified IoT architecture. Whenever you are designing a product, remember these three things. One is node, network, cloud. Node, network, cloud. These three things are essential in building any IoT product. Okay, so what is a node? Node is basically sensor node, or it can be a control node, or can be sensing and control. Both are existing in a node. So let us take a simple example. As we discussed, it can be a microcontroller plus sensors. sensors plus connectivity. So this is called as basically node. Node interacts with the physical environment, like it interacts with the plant, or it interacts with the human beings, or it can interact with other things. Okay, so it interacts basically with some environment, right? For example, you are monitoring a machine. So then these sensors should interact, these nodes should interact with the machine, right? Machine temperature, machine vibration, machine current. Okay, so we want to measure all those parameters. In such case, we have to keep the node with the machine. Okay, Rafi, right? Once you collect the data into the controller, so here this is a microcontroller. Inside of the microcontroller, we are collecting data. Once we collect data, the next step is you can process the data locally inside of the microcontroller, or you can send the raw data to the cloud, all of you. So to send data from microcontroller to the cloud, basically this microcontroller should have internet access, because cloud is available in the internet. Remember, cloud is available in the network. Okay, internet, it is available in the internet. So your microcontroller also should be connected to the internet. If it is having internet access, then microcontroller can connect with the cloud of it. So the goal is how to connect microcontroller with the cloud. Okay, so to connect microcontroller with the cloud, basically you need communication protocols. Okay, you need communication hardware like Wi-Fi hardware or Bluetooth hardware or maybe Ethernet hardware. So any of these communication technologies you need in order to connect your device to the cloud. Once it is connected, see all of you, once your microcontroller is connected to the cloud, the next step is, you can push the data from microcontroller to the cloud. There are different types of protocols to send data from microcontroller to the cloud. Simple example is HTTP protocol to send data from microcontroller to the cloud, or you can use MQTT, message queue telemetry transfer protocol, or hypertext transfer protocol, or you can use QoAP. Okay, these are all different protocols for sending data from device to the cloud or from client to the server. Okay, so once data is available in the cloud, then we can visualize the data. So to visualize the data, we may build apps, maybe mobile apps, or you can build web dashboards. Okay, either of these you can try using. So either you can try with the mobile apps, or you can go with the web dashboard. Okay, you can use anything. In our case, what we are trying to do is, so we are going to use a Raspberry Pi plus DH11 sensor. So in our case, we are going to use Raspberry Pi as a our development board in place of this microcontroller. So I'll be using Raspberry Pi development board, and sensors are readily available sensor I have with me. DH11 sensor, that is temperature and humidity sensor. So I'll be using temperature and humidity sensor. Okay, so we are interfacing temperature and humidity sensor with the Raspberry Pi. Once we interface, the next step is I'll be sending this data to the cloud. To send the data to the cloud, basically I'm using here AWS Cloud. AWS. Okay, so we'll be sending data to AWS Cloud. From AWS Cloud, I want to visualize data in QuickSight platform, QuickSight. So these also actually are AWS service. So we'll be using AWS service to visualize sensor data as well. Right. So the next step, all of you, I'll be showing you here. So basically, IoT devices generates data. Remember, IoT devices generate data. There are billions of devices today existing in the industries. So these devices continuously generates data. This data is increasing exponentially. So and this data is available in different formats. Okay, and for example, it can be image data, or it can be numbers, or it can be time series data. So this data is available today, and we are going to use this data. Okay, so I'll be showing you how we can use this data, okay, for making better decisions. Okay, so you see data analysis or data visualization, machine learning, so or deep learning. All these technologies are existing for better decision making, right? So it makes our decision making better and accurate. Okay, so we go with data analysis, or we go with the data visualization or machine learning, mainly for making decisions, right? So to make the decisions, you need data. IoT devices are generating data, and there are many things, right? Website generates data, e-commerce generates data, social media generates data, sales, CRMs, okay, or maybe some other platforms, they are generating data. So everywhere you see that data is being generated. Even IoT device also generates data. So we are going to use this data for making better decisions. Okay, so how to do that? I'll be showing you now. Right, all of you. So basically the value, there is a greater value in data of you. Okay, so you will see that in the Economist article, the world's most valuable resource is no longer oil but data. Okay, so today the data plays an important role in order to increase the revenue or to expand the business or to scale. Okay, basically the data plays an important role in making such decisions, whether to go for marketing or to invest in the marketing or hiring somebody, okay, or expanding business to some other country or to some other state. Okay, so all these decisions requires basically some intelligence, right? So this intelligence is derived from data. Okay, of you. So we are going to see this now, how we can do that. Right. So basically, we'll be seeing data-driven decision making. So all these tools like QuickSight or Microsoft Power BI. So QuickSight is very similar to Microsoft Power BI. So these tools are very helpful for business intelligence. So you can directly see the data and you can visualize the data, and based on that you can make decisions, better decisions. Okay, and even you can apply machine learning algorithms as well. Okay, so we are going to use this QuickSight. Okay, AWS QuickSight, all of you. So this AWS QuickSight is cloud scale business intelligence service. Okay, it is hosted and available in AWS. So you can use this QuickSight to deliver easy to understand insights. So anyone can easily understand insights by using this QuickSight tool. And so that people who are working with this QuickSight, they can easily understand wherever they are, it is available online. Okay, so this tool is available online, so anywhere they can visualize data and they can take better decisions based on this data of it. Right, so there are different purposes basically QuickSight is being used. So this QuickSight is built for everyone. It is for everyone, not for end users. Okay, not only for end users but for others also. End users, what they can do is they can see the data, and based on that they can make better decisions. Okay, so end users will see the dashboards. Okay, they don't build the dashboards, but they can actually use the dashboards. For example, you build a dashboard with a data visualization. Okay, like you have some gauge or a bar chart or a pie chart. So you build some beautiful dashboard. Suppose in the dashboard you are showing all the graphs. Okay, how a particular variable is varying or how a particular attribute is changing. Okay, you want to show everything in the dashboard. So you can show that, right? So you can show how current is varying, how the vibration is varying, how temperature is varying. So you can show everything in a beautiful dashboard. Okay, so end user can make better decisions by seeing that particular dashboards. So end users can use directly dashboards. They can visualize data in app, or they can visualize data in mobile app or in the web app. Okay, and business analysts, what they do is basically they create these dashboards. Okay, they create dashboards by using AWS QuickSight. Okay, and they give those data, dashboards to the end users so that end users can see and make decisions. Whereas developers, what they do is they try embedding these visualizations into apps. Okay, for example, you have a big website. Okay, so there is a complex website you build. Okay, and you want to show all the graphs in that particular web dashboard. To do that, or you want to integrate into that particular application, to do that, so developers can do that by in QuickSight. So QuickSight offers developer friendly environment where developers can integrate these services into basically web applications or into applications. Okay, they are building. So that is advantage. Another one is admins. Okay, so admins, it makes admins work so easy because there is a auto scaling available. So auto scaling means if there are 100 users today, tomorrow there may be 1,000 users. So if there are 100 users or 1,000 users, so based on the number of users, this particular data will be based on that data visualizations will increase, or number of viewers for these data readers. We can say viewers are readers who see this data, that is end users, maybe 1,000 end users. You can auto scale it. There is a possibility in QuickSight, AWS is providing, you can auto scale to 1,000 users. Okay, so that is advantage. And pay as per the user. Okay, so for example, pay for use, right? There are 100 users, pay for 100 users. If there are 1,000 users, pay for 1,000 users. So there is a cost benefit analysis. If you do that cost benefit analysis, so auto scaling will help a lot. So it reduces the work of admins. That is advantage. And another thing, you can see what you can do with AWS QuickSight. You can connect and scale all of your data. So you can connect a CSV file, or it can be Excel file, or it can be SQL data, or it can be data from IoT devices. So data can be from any file, from any source. Okay, it can be from any source. You can connect the data to the QuickSight and you can visualize. Okay, that is advantage. And you can build customizable dashboards in QuickSight. Okay, so you can build your own customizable dashboard. You can do everything on your own. So there is a facility in QuickSight. And even you can leverage ML integrations for insights also. Machine learning also can be added to the QuickSight to show better insights of the data. You can leverage ML as well. And another one is you can enable true self-service BI to everyone. Okay, so it's not somebody comes and do that, but you can do that on your own. Okay, that is self-service BI for business intelligence for everyone. And native AWS service integrations also available. So there are different services you can directly integrate with QuickSight, like notification services or IoT analytics services. Okay, there are different types of S3 buckets. Okay, there are many services you can integrate with QuickSight. So there is no need to manage servers on your own. You can pay by usage. Okay, so you can pay by usage. That is advantage of another advantage of QuickSight. These are the benefits of it, right? So now we will see the quickly how this AWS QuickSight works for data visualization, IoT data visualization. So there are 4 important steps. This is step 1, step 2, step 3, and step 4. So in the step one, what we can do is we can connect our data. So you have to connect your data to QuickSight. So data set may be available in AWS Cloud. For example, IoT data, you are generating IoT data. That IoT data is available in AWS Cloud. So you can use this data available in AWS Cloud in the second step. Okay, that is in the analysis. Okay, you can create a data set. So data set, getting a data set is important for analysis. So getting a data set can be from anywhere, like AWS Cloud, or from some corporate data center. Okay, or you can get data from some files like CSV, XLSX, or JSON files. And there are some SAS files also may be available. So you can connect any of these data files, okay, to the AWS QuickSight analysis data set. So once you connect, then you can prepare the data. So sometimes data may not be, suppose there are many columns, you want to remove some columns, you can remove some columns, or you want to remove some rows, you can do that. There is a step called as prepare data for analysis. After preparing, you'll be creating a data set. Once data set is created, you can use this data set for analysis. So step 1 and step 2 is all about preparing a data set, collecting and preparing data set. Once data set is collected and prepared, the next step is, we are going to analyze. Okay, so to analyze, so you'll be using QuickSight, visualizations. There are different types of visualizations available in QuickSight, like line plot, bar chart, gauges, area plots, heat maps. Okay, there are many visualizations, as you know, in Matplotlib, in Python, or Power BI, business intelligence tools, or maybe some other tools. So the same type, but here it is very simple. You can drag and drop, and you can visualize the data. Okay, it's super fast with the AWS QuickSight. In the step 3, we'll be analyzing the data that we prepared. Okay, in the step 2, after analyzing, okay, you can build a beautiful dashboard, and you can use this dashboard for better decisions. In the step 4, you can continuously visualize data, and you can make decisions based on the data of it. Okay, so these are the 4 steps. This is a workflow. So how we are going to do that is these are the 4 steps generally you have to use to work with the AWS QuickSight. Right. So I'll be showing you some demonstration how we can do that. Okay, so that you will understand more details. So if you see workflow of our IoT data, visualization. So we have IoT device with us. So this IoT device, we interface Raspberry Pi and DH11 together. So DH11 sensor. What is DH11? DH11 is digital humidity and temperature sensor. Digital humidity and temperature sensor. So we interface digital humidity and temperature sensor with the Raspberry Pi board. Okay, and we are collecting temperature and humidity values in the Raspberry Pi board. And after that, we will be sending this data from Raspberry Pi to AWS IoT Core. So in AWS Amazon Web Services, there is a service called as IoT Core. This IoT Core is to collect data from devices, IoT devices or IoT gateways, from IoT devices or from IoT, basically IoT devices or gateways. We can say gateways. From device or gateway, we will be sending data to the core, all of you. Once data is sent to the IoT core, in the core itself, we can create a rules. Suppose you want to use this data for analytics, or you want to use this for QuickSight, or you want to use this data to send notifications. Okay, so we are getting temperature and humidity values to the IoT core. That is one thing. Collecting data is one thing. Once data is collected, you can apply basically different rules, like sending SMS, or sending push notification, or sending email, or sending data to S3 buckets, that is storage buckets in AWS, or you want to store data in DynamoDB, that is a database in AWS. Okay, you can do many things. So IoT Core, what you do is, there are 2 things you can do. One is collecting data from devices, and from here you can create a rule to send data to S3 or database, DynamoDB database. So you can interact with all different types of AWS services here. So S3 is a storage service, DB also storage service, or you can write program to do some, some micro, there are functions available. You can use Lambda function, which is serverless. Okay, a Lambda is a serverless one. Okay, you can run program here to do some analysis on the data, or you can directly use IoT analytics with this. There are many other services are there. So you have to use a rules concept to do that. So one is collection, another one is rule. Okay. So to send data from here to here, you have to write a program. So you can write a program in Python, or you can write program in JavaScript, or you can write program in C programming. Okay, you can use any of these. Right, all of you. And then once data is available, the next step is we want to send data from here to IoT Analytics platform, where we'll be creating a dataset. Once dataset is created, this dataset we'll be using in QuickSight for visualization. So we are visualizing the same dataset in AWS QuickSight of you. This is what we are going to do. So these are the steps we are following in our demonstration of this particular concept. Right. So I have interfaced Raspberry Pi with the DH11 sensor. So there are 3 pins here. One is VCC, data pin, and ground pin. And VCC I have connected to 3.3 volts, and data is connected to GPIO 21 pin. ground is connected to ground. Okay, and then I'll be writing a program inside of this Raspberry Pi, and we can run Raspberry Pi to read the data. That is the next step. Okay, so once we done with the interfacing, the next step is we can write the program. So I have written the program to get the data into AWS IoT Core. I'll be showing you, all of you. So you can see here, IoT Analytics platform and QuickSight platform. So I'll be showing you AWS now. See AWS, go to Google. To do this project, what do you need? Basically, you need AWS account. You have to create AWS account. So you have to create one, and also you need Raspberry Pi board, and then you need DH11 sensor also. Okay, so AWS account, and also you need Raspberry Pi and DH11. Okay, in AWS there are many services. So I'll be opening this AWS website. Right. So you have to sign in to the console. Sign into the console. So once you create an account, you will get this. You can sign in with your user credentials. Now there are different services. When you click on this, AWS provides many services like analytics, application integration, AR, VR, AWS cost management, blockchain, business applications, compute, and there are many. You can see Internet of Things, machine learning, okay, and storage, robotics, satellite. So it covers almost all applications and all of these services that we need. Okay, so you can get everything here. So business applications and also compute, containers. So everything is there. So we are interested in IoT Core service. There is a IoT Core service in Internet of Things. When you go to AWS, you will see Internet of Things. When you see Internet of Things, you will see IoT Core. This is to connect device to the cloud and get collect the data. So click on this IoT Core. So this is AWS IoT Core, all of you. In this AWS IoT Core, we have to get data from IoT device. Already I have connected this IoT device. So this is my IoT device. I'll be connecting now to my device. Okay, this is a VNC, virtual network computing application. So using VNC, real VNC, I'll be connecting to Raspberry Pi virtually from my computer. So done, I have connected. Okay, so I have written a program here in the Raspberry Pi. I'll be showing you where I have written the program. These are my certificates, right? So I have the program written here. I have written the program. I'll be showing you now. So it is there in the folder. So I have created a folder and kept the file here. There are different files I have here. So I'll be working with this AWS IoT 1.py. This is a program I have written for connecting my Raspberry Pi to AWS IoT Core. This is the Raspberry Pi dashboard. All of you can see this is the Raspberry Pi desktop. All of you. So this is the main. All of you can see this here. Okay, you can control this particular Raspberry Pi from anywhere in the world, provided that it is connected to internet. Okay, so this is my Raspberry Pi desktop. All of you can see the Raspberry Pi desktop. Okay, I'm accessing from my computer. Okay, right. So it is near to me. So what I'm doing is I'll be connecting this Raspberry Pi to AWS IoT Core. So how to do that? To do that, it's a very simple. We need basically three things. All of you remember it. To connect Raspberry Pi to AWS IoT Core, the first step is you have to create a device. Yeah, this session is up to 7, all of you, 7 o'clock. Okay, we'll close at 7 p.m. right? So we have to create a device. Okay, so once you create a device, then we have to do everything in the AWS IoT Core. Okay, you have to create a device, and then you have to generate certificates for security certificates, and you have to create a policy. I'm giving overview of all these things of it. So create a device and then create a certificate and policy. Once you create a certificate and policy, then you'll be downloading those certificates onto your computer. Once these certificates are downloaded, So you can use them to connect your device to the AWS IoT Core. Remember, without certificates, we cannot connect our device to the AWS IoT Core. So first step is you have to create certificates. After creating certificates, you can connect your Raspberry Pi or any other microcontroller to the cloud. Okay, so I'll be showing you how to do that now. So already I have created a device here. If you go to all devices, so you can see here, all of you go to all devices. In that you will see things. Okay, go to things now. In the things, I have created one thing here, IoT and RPI. This is for demonstration purpose today. I created this device, IoT underscore RPI, and certificates also generated. I have generated, these certificates were downloaded. So already I have downloaded these certificates. Okay, so created today only at 1, okay, for demonstration. Okay, and these certificates are valid, and these certificates are very helpful for, is required for connecting your device to the AWS IoT Core. And policy also there. So policy is to send allow, like all the resources to access, and also to do like publishing, subscribing, means to send the data and also to receive the data. So all these things are available in JSON. You can see that effect allow action. Here star indicates, asterisk indicates everything, allow everything, resources, allow all the resources to access. Okay, this is the basic policy we have created. So I have created this device, all of you, and the certificates are available here in Raspberry Pi. We need to keep them in the Raspberry Pi. So I kept all the certificates here. So these are my certificates, like Amazon root CA certificate, private, pem.key, and also we have public.pem.key and certificate.pem.crt. These are the important certificates we need in order to connect our device to the AWS IoT Core. Okay, right. So now open the program. So I'll be showing you the program. So you can see here, this is a program I have written. So this program is to connect our Raspberry Pi device to AWS IoT Core. So this is my address. Okay, device address is the endpoint address. Okay, you can find endpoint address in settings. Okay, in the settings you can find this. So this is the endpoint address. This endpoint for MQTT, at the same time for HTTP based REST API also the same, right? So I'll be sending the data from here already. So I'm measuring temperature and humidity values continuously, and after that, this is a code to read temperature and humidity. I'm reading temperature and humidity values, and after that, I'm printing temperature, humidity, and also publishing the data using MQTT to AWS IoT Core. Okay, and this data will be continuously updated. So this is purely based on MQTT, all of you. So I am publishing data to IoT data topic. Okay. So this Raspberry Pi is sending data to the IoT data topic. The values are temperature and humidity. We want to read that data here in our IoT code, right? So I'll be running this program now in Python 3. I'll be running this in Python 3. So I'm running this program in Raspberry Pi. So I'll be reading temperature and humidity values and updating this data to AWS IoT. So temperature is 30, humidity is 54, and my device ID H123, temperature is 30, humidity is 54. I am publishing that to IoT data. So I want to see this data in AWS IoT Core. So you can see that data in AWS IoT Core. Go to your here MQTT. So you can see that here MQTT test client. You can see the data coming from Raspberry Pi. Subscribe to this topic. So hash, or you can subscribe to IoT data. Subscribe now to this. Now we'll be getting this data to AWS IoT Core cloud. Okay, so ID, temperature, and humidity. We are getting continuously this data published to AWS IoT Core. So from Raspberry Pi, we are getting this data to IoT Core. Once we get this data to IoT Core, we want to get this data into IoT Analytics. So how to send data from IoT Core to IoT Analytics platform? To do that, I have created a rule, all of you. So here there is a rules, message routing. In the rules, I have created a rule, Apple and 1. So this rule is basically, I want to select, this is SQL statement. I want to select timestamp as TS from IoT data, and I want to select all the JSON objects like temperature and humidity values from this. Okay, so we are getting this data. So what is the data we are getting? Temperature data, humidity data, and also timestamp. And we are sending that data to IoT Analytics platform. Okay, to this IoT Analytics platform. In this IoT Analytics platform, you can see data sets. I have created data set here. I have created first channel. So this is a data channel, and then I have created a pipeline to send data from IoT core to data sets. So there is a data store created and also data set created. You can see this data set here. You can see the contents of data. So you can open this. So I'm getting continuously from AWS IoT Core into IoT Analytics platform, like 30, temperature, humidity 51. So timestamp, this is the timestamp. Okay, this is the date. So you'll be getting all the data continuously into this platform, all of it, IoT Analytics platform. So data first sent from Raspberry Pi to Core, IoT Core. In the IoT Core, we have written rules. From IoT Core, we send data to Analytics platform. Analytics by using rules. In the Analytics platform, we have data set. So we are going to use this data set for visualizations. All of it. We are going to use this data set for visualizations. Okay. So where to visualize this data? To visualize this data, we are going to use QuickSight platform. So you can open QuickSight platform. This is basically QuickSight. You can open the QuickSight from here. So search for QuickSight, all of you. So open the QuickSight. Once we open the QuickSight, now dataset is available in IoT Analytics. So dataset name, you can find the dataset name here. So dataset name is IoT data. So these are dataset names. You can find IoT dataset here, all of you. This is a dataset one. Dataset one is basically IoT dataset name we have given, right? Dataset one. So we want to use this dataset one for visualizations. So go to QuickSight. This is a QuickSight website. And to start analyzing data by using QuickSight, basically these are default data visualizations. When you open QuickSight, so these sample data analysis will be available, like people overview analysis, sales pipeline analysis, web and social media, business review analysis. So all these things are available. Basically, you can analyze any type of data here in this QuickSight of you. Okay, this is the QuickSight platform. So I'll be showing you how to use this QuickSight now for our use case. Okay. So let us see here, all of you. Go to new analysis. So already dataset is available here, dataset one. So this is the IoT data I have created. If you want to create a new dataset, you have to click on new dataset for visualization. Suppose you want to upload some file. You can upload some file also. Suppose upload a file from here. On the desktop, I have a file. Here is dataset. That is a flower dataset. So we can upload a dataset directly from your computer. So now I am uploading a dataset for data visualization. This is a CSV file, comma separated values file. So these are dataset I have uploaded, like sepal length, sepal width, petal length, petal width, and variety of the flowers. There are 3 types of flowers covered in this dataset. Okay, you can prepare the data also. There is a edit settings and prepare data. You can click here to prepare the data also. So you can see this is the data type is decimal. This data type is decimal, and the variety is Setosa. Okay, this is the for uploaded data. This is not IoT data. These are some file I have uploaded. You can also try uploading. Once you make changes, what you can do is you can publish and visualize. There is an option called as publish and visualize. So here you can visualize the data of it. So for example, I'll be taking this donut chart. Click on this donut chart, and you will see here, all of you, the donut chart. Once you create a visualization for this, so now 100% success, 150 rows were imported to Spice, 0 rows were skipped. So all the data is loaded now. Now we will do analysis. We will plot some visualizations here. Suppose let us take here variety, keep here group variety, and see the analysis. So directly you got Setosa, there are 50, and Virginica, there are 50, and then versicolor, there are 50. Okay, same way you can analyze, you can draw some plots also, like histogram plot. For example, take a histogram, and in the histogram you can add a value here. For example, petal length. You can add a petal length here. You can see how this petal length is distributed, distribution of petal length. Okay, so this is how you can basically create a dashboard, how the petal length is varying, what is, basically how many values are there. 37 values are there between 1 and 1.59, and there are 13 values between 1.59 and 2.18. So you can see there are no values between 2.18 and 2.27. So you can see how you can create a histogram. Okay, lovely. And even you can create other plots also. You can add visualizations here. Click on add visualization, and for example you can try, suppose, heat map. Okay, so you can add some heat map also. You can add here dimensions, rows, variety. Okay, these are heat map. So setosa and columns also you can try with some petal length or petal weight. You can try with the different plots. This is the heat map for this particular petal length. All the other flowers also you can see here. So this is how you can visualize data sets, all of you, using QuickSight. You can save, even you can save this, or directly it is available as iris analysis. You can go to QuickSight. You can go to QuickSight and you can find this. Okay, this is the analysis that you have created just now. Right, this analysis we have created. Even you can create a, you can share also, you can export also, you can do all these things. Okay, lovely. This is about basic analysis, and you can select the themes also, and you can change settings. For example, you want to keep midnight, so you can keep a visualization like this. Okay, there are different types of visualizations you can see here. Right, all of you. This is about data visualization for this iris flower data set. For IoT data, so already we have IoT data set. Already I have connected IoT data set. You can click here new analysis, and you will see your data set. This is data set 1. This is what I have connected. Okay, and you can visualize the data. So edit data set, and you can visualize this data. Last refresh November 12, 2025, 5:36 p.m. Okay, you can see this. So string, edge device, integer, date. So these are the basic columns you can find, and these are the different values we have. So these are the data updated from our our Raspberry Pi device, IoT device, and you can directly publish. Okay, directly save and publish. You can do that, or you can cancel. Already I have done that. Okay, so no need to do that. So if you want to analyze, you can directly analyze that. Okay, go to dashboards. You can create a dashboard also from here. Beautiful dashboards also can be created. You can create your own dashboard, one dashboard here also. So go to analysis now. In the analysis, so we want to do analysis using data one. So click here for visualization. Click on use in analysis. Click on use in analysis. Now this is the IoT data. So there are total 1543 rows are imported. 100% success, all of you. And now you can visualize the data. Suppose we want to visualize. So one second. So we want to visualize, suppose, area plot of some humidity. So click on this. Click on this and add here humidity. You can see the area plot, how the humidity is changing, how these values are changing. Okay, so the area plot of the humidity, or you can take basically a donut plot. So you can see how the values are varying. You can see the donut plot also, or you can add another visualization. You can add here clustered bar chart, add a dimension, add temperature here. You can see the bars, temperature bars here, right? So this is basically how you can visualize directly IoT data. So we are getting the same data here, and we are visualizing this data in IoT data in QuickSight. This how you can visualize data in QuickSight. Okay, and there are many other things you can do, like custom visual content, or you can even text visualization. you can do scatter plots, and there are other data type visualizations are there, right? So this is about how you can visualize data using QuickSight, all of you. Okay, this is a basic introduction to how to visualize IoT data using QuickSight. Okay, so thank you so much for attending. Okay, so if you are a new beginner, okay, so how to learn this or how to go beyond basic things. So first you need to know how to build IoT devices using Raspberry Pi and Python, and you should know AWS services for IoT like IoT Core, IoT Analytics. You have to explore, and for data visualization you can explore QuickSight. Okay, so this is a very promising field today. There are many opportunities for research, job, and career prospect. Okay, so this is about all AWS IoT data visualization using QuickSight. All of you, if you have any doubts, you can ask me. Right, with this I'll be stopping my session here. Any doubts, you can ask me. Thank you. So this is somewhat we went very fast somewhat. Okay, but basically I want to give you all overview of this particular IoT data visualization using QuickSight. Okay, right, any doubts, all of you? Pujida, Nitin, Richi, Rohini, Juma, Patel, Vishwapriya. Right.
Thank you, sir. I think it's a great insight you have provided us. Thanks for that.
Yeah, thank you, Nitin. Thank you so much. Thank you, all of you. Yeah. So now you can leave, and if you have any doubts or if you want to interact, you can.
And one before that, sir, I think I saw on WhatsApp that you are going to have some series of some lectures, right?
Yes, Nitin.
Okay.
Every Saturday we'll be having a session. Okay, in the evening from 5 p.m. to 6 p.m. IST for the upcoming sessions. Okay, so I'll be sharing everything in my LinkedIn. Okay, so if you don't have access to my LinkedIn profile, you can access the LinkedIn profile where you can find all the details, all of it.
Yeah.
So just follow me, and you can find all the articles or whatever maybe the webinars or the training programs. You can find them. So I'll be posting all these things. Okay, right. So I'll be showing you my profile. Just 1 second. So these are my profile, Bapuji Kanpati. You can follow this profile, all of it, right? And then you can get all the notifications regarding training programs, upcoming training programs. Okay. Right. These are all short things, and if you want to really learn, you can ping me or you can ask me. For example, if you are in the middle of something and you want to explore more, you can ask me. Okay, right.
Sure. Thank you so much, sir.
Thank you so much. Yeah. Thank you all.